Video number 3 for Chapter 8. Again, I have a special guest. This person was reading some bedtime stories with my 2 daughters, and I said, hey, would you like to come be a part of one of my stats videos? And he was like, totally. Yeah, I would totally do it. So, guys, I have a very special guest. Here is Elmo from Sesame Street.
Hi everybody, it's me Elmo. I really like numbers and letters.
We're going to look at some letters today, Elmo. We're going to look at some variables.
Variables? What are you talking about?
Well, it's probably going to be really over your head, Elmo. I doubt you probably see too much of this on Sesame Street, but if you see anything you recognize, just let me know. Just let me know, little guy, okay?
Okay. I'm not going to be too ticklish about this stuff, am I?
No, you're probably not going to be too tickled about this stuff, Elmo. Alright, so earlier we discussed about the definition of a confidence interval being a point estimator, and that was our statistic, either an x-bar or a p-hat, and then plus or minus a margin of error related to how confident we were about capturing the population parameter of interest, and whether that was mu if we were talking about mean problems, or p if we were talking about proportion problems. Now, our formal definition, we're not just going to say it's a certain value plus or minus, how confident we are. We can really now break it down into something a little bit more mathematical in saying that it is our statistic, which is our point estimator from up here, plus or minus. Now, this is still considered our margin of error. Okay, this plus or minus part, we will still refer to it every once in a while as the margin of error, but the margin of error is made up of 2 individual pieces. It's consisted of a critical value and a standard error part. The standard error part will look very familiar. The critical value part will look familiar, but we will have to calculate some values for those critical pieces. So Elmo, what do you think so far?
Yeah, I am like really lost. I have no idea what's going
on. That's okay. We'll just keep going.
Okay. Can I leave?
No, you can't leave yet. You can't go back to Sesame Street.
Okay.
So, the part after the plus or minus is our margin of error that I said can be broken down into 2 parts. The critical value is the part related to the how confident we want to be. 90%, 95%, 99% confidence. The standard error of the statistic, that's just our standard deviation for our sampling distribution that we did last chapter. And it depends on, whether we're talking about mean problems, then we would use this formula for standard deviation, or we would use this formula if we were talking about a proportion problem. Now, one thing that looks a little different about this one, you'll notice these have p-hats, and before they were just p's. Okay? Now, the thing is, we don't know what the population proportion is. So how are we going to know what to plug into it? Okay? What we do know is a p-hat value. We have a sample proportion, and so we're going to use that sample proportion p-hat to estimate what p represents. So still in your formula sheet it says p, but p is unknown when we're really going to calculate confidence intervals. So we're just going to plug in p-hat. That's the next best thing we have for p. Okay? So our statistic plus or minus critical value times standard error of the statistic really looks like this. Okay? Here is our statistic. Here's our p-hat. The critical value is nothing more than a z-score. How many standard deviations away we are from the mean. Okay? And we'll talk about some specific values. And then the standard error, well, that's really the standard deviation of our sample proportion problems. Okay? And again, notice the p-hats here because we really don't know what p is, so we can substitute it in for p-hat. Okay, it's still a p, just add a hat to it. Now, you won't see exactly that formula there. Let me jump back real quick. You won't see this on your formula sheet. This is what you will see on your formula sheet. It says confidence interval, statistic plus or minus critical value times standard deviation of the statistic. Now, statistic, they're telling you here in this table, statistic will either mean sample mean, which is an x bar, or statistic means, depending on what kind of problem we're doing, a sample proportion, which is a p hat. So this will either be x bar or p hat, plus or minus. Critical value, for right now, will be a z-score. Later in the chapter, we'll talk about a t-score, which is very similar to a z-score. And then standard deviation of the statistic. Notice what it says right here, standard deviation of the statistics. We're either using this, which is for sample means, or we're using this, which is for our sample proportions. And notice here it says p, but we don't know what a p is, so we say p hat. Okay, so again, it doesn't look exactly like what I just showed you in your formula sheet, but you kind of have to, fill in the blanks.
We like to do fill in the blanks sometimes on Sesame Street.
Yeah, I'm aware, Emma. I've seen the show.
Okay.
Now, conditions. These are basically the same conditions before that I mentioned in the previous video with Lindsay Lohan. So, fill in some of the blanks that I have here. And really, I'm not going to dive too much into reading all this. You guys are, seniors. You guys can read this stuff, and I've pretty much spelled it out for you. That if something's not met, then this is what you have to write. If something is met, then this is what you write. Okay? So you guys can fill in those 3 blanks for 1, 2, and 3. It's the same exact 3 conditions we talked about in the last video. So just read over that and make sure you follow it to the T. Now the last part I want to talk about is that Z part. Okay? Notice it said Z star. And the reason why I put Z star is because that Z value can change values. It really depends on how confident you want to be. Now, if you remember, way back when, we had the 68, 95, 99, 7 rule. And that really said, if we were 1 standard deviation above or below the mean, 2 standard deviations, or 3 standard deviations above or below the mean. Okay? Now, we can kind of use this. That 1, 2, and 3 standard deviations, well, that's a z-score. Okay? So when we look at a 68% confidence level, and there's never a time that we're going to be 68% confident. We're definitely going to be, at least 90% enough. But just for the sake of using the 68, 95, 99, 7 rule, in a drawing, we would be 1 standard deviation away from the mean. Okay? So the mean's right here in the middle, and we would just scoot over 1 standard deviation above and below, and that was 68%. Okay? Now, the 68, 95, 99, 7 rule isn't an exact rule. It's an approximation. So the z-score is not going to be 1. It's going to be really close to 1. But I want to show you how you actually calculate that value. Because if I gave you 90% or 99% or 98%, the 68, 95, 99, 7 rule not going to help you out. You're going to know in between what whole number values your z-score is, but you're not going to be able to figure it out just from that. Now, in order to calculate this stuff in your calculator, we need to know the tail area. And by the tail area, we're going to be referring to this guy down here. Now, the tail area, the whole curve is 100%. And if I subtract away my 68% that's in the middle, my 2 tails here together make up, what, 32%. So that's why I'm going to divide it by 2. I only want to talk about one of the tails. And it really doesn't matter which one, but I'm going to stick with this left one. So that's going to give me a tail area of 16%. Okay? And to figure out that tail area, a probability of 16% is related to really how many standard deviations. So in your calculator, it's been a while since we've used inverse norm before, but it's right below normal CDF. And you don't really have to put in this 0 and this 1 here, which this is the only time I put it in, because we're talking about a standard normal curve that has a mean of 0 and standard deviation of 1. So really, if you just type in inverse norm 0.16, it gives you, wrong one, it gives you the z-score, how many standard deviations away that tail is. And really, we said we should expect a value of 1, using the 96 or the 68, 95, 99, 7 rule, but really it's 0.99 to be more exact, and this is the number you should use. If you use 1, it's still okay. Okay, but this is how you get the exact value.
Mr. G, I am still totally lost.
Elmo, it's cool, dude. It's cool. Just sit tight. I'm almost done.
Okay.
Now, 90% confidence. We want to have the middle 90% taken up. So that means we're going to have 10% in our tails. How much is in one tail? We would have 5%. Okay, so again, we do inverse norm, 5%, 0.05, and we get a z-score, a critical value here, of 1.645. All right. If we do 95, well, 95 was 2 standard deviations, so we would expect to get 2 here, and you can use 2, but again, I want to show you what really the more exact value is. So 95% in the middle, which means we have 5% in the tails, and in one tail, we have 2.5%, 0.025. So inverse norm 0.025 is 1.96, which is pretty close to our 2 that we would get from the 68, 95, 99, 7 rule. 99%. 99% in the middle. We only have 1% in the tails, which means we only have 0.5%, 0.005 in one tail. So inverse norm 0.005 gives us a little over 2.5 standard deviations away, 2.576. Now, I would say, without a doubt, most of the time you're going to be dealing with one of these 3 levels of confidence. So it might be pretty helpful to memorize those 3 values there so you don't have to go back and recalculate them. Okay? In 99.7, again, we should expect that to be 3 from our 68, 95, 99.7 rule. If you got 99.7 in the middle, that means you have 0.3% in the tails, which means 0.15% or 0.0015, an inverse norm of that gives us 2.968, which is, again, close to our 3 standard deviations we would get. Now, what if it's not any of those 5 that we just discussed? What if I gave you a custom confidence level? Then what you would really have to do is pretend, here's your C%, whatever that is. So to figure out how much is in the tails, now notice you can hopefully see the pattern that's emerging here. The only thing that changes in these things here is the confidence level. So we always take 1 minus our confidence level, and we divide it by 2 to only talk about one of our tails. So whatever 1 minus C divided by 2 is, that's what you put into inverse norm. Again, whatever that is, I put it right there. And then you can figure out that's the z-score that I need to use for that particular confidence interval. Okay, so Elmo, did you learn anything?
Oh my gosh, I am totally leaving the next time I get done with bedtime stories because these are crazy tough.
Well, my students in class, they think this stuff is awesome,
I highly, highly doubt that, Mr. G. I'm going to go cry now to Big Bird, and I might have to go eat some cookies for Cookie Monster.
All right, Elmo. Well, it's been fun. We'll catch you later, bro.
All right, see you, dude.